Hi, class. So what we're going to look at now is alkanes and talk about some terminology, and then we're going to flow into actually being able to name alkanes. All right, so just a couple terms early on, just to make sure we're all talking about the same thing. The first one is hydrocarbon. And you've probably heard about this, especially as there's more of an environmental emphasis and people are becoming more environmentally conscious about what a hydrocarbon actually is. This one's actually one of the nice ones where the name actually tells you exactly what's in it. A hydrocarbon is a molecule that's made up of carbons and hydrogen, right? So that's where the term hydro for hydrogens, carbon for carbon, right? So just a molecule made up of hydrogens and carbons. Now, where it gets a little more specific, and you've probably actually seen these terms saturated, unsaturated on the back of food labels, is we're really talking about if it's saturated, it has all single bonds. And what we're saturated with is the most number of hydrogens possible. If it's unsaturated, that means you're missing some of those hydrogens, right? You've lost some of those hydrogens. And what we typically replace them with is a double bond or a triple bond, right? Now, when you see the term unsaturated, it doesn't actually give you any insight into where that double bond is, how many double bonds. You know that there just has to be at least one, right? And the same thing for the triple bond. But having at least one double bond or triple bond really does change the dynamics of the molecule, right? And I think you see on food labels, you see saturated fats and unsaturated fats, right? And that's where these terms come from. And we'll actually get to it a little bit later when we talk about alkenes, but the unsaturated fats actually have the direction of the double bond, right? So we can kind of look at that as well. The next one, alkane. So an alkane and a hydrocarbon, essentially the same thing, right? It's just a hydrocarbon that's in an open chain, right? So we're going to talk about rings and then just the straight kind of normal chains. That's what an alkane is. And aliphatic carbon, some people use it. I won't really use it very much, but it's another term for alkane, right? So these are just terms you should be familiar with as we kind of go through. And again, just to make sure we're all talking about the exact same thing. If we're looking at the structure of an alkane, it's going to have a tetrahedral center. So I think we talked a little bit about this when we did the zigzag. All right, so it's going to have a tetrahedral center, which means you should commit this number to memory. It has a bond angle of 109.5. Right, and so that's the distance. If you did the bond angle from hydrogen, carbon, hydrogen, that distance in between the two. As you can see this three-dimensional picture, some of the groups are pointing back and forward and then up. And so the way we would draw this in 2 dimensions is if we wanted to show that methane, which is 1 carbon, you could draw it here. And then we typically use the wedge, which means coming out towards you, and dash coming out. And so that's the other way we can do the tetrahedral. Right? So it's a way to give that 3-dimensional feel to it for something that's 2-dimensional on a flat piece of paper. Okay. Now, it doesn't really matter if it's carbons or hydrogens. We're pretty much going to always keep that 109 bonding, right? And so it'll kind of split out throughout the molecule. One other term that you probably heard in Gen Chem is constitutional isomers. All right, so constitutional isomers, and I think you may have heard me use this term, this kind of analogy before, but it's a bunch of Legos, right? So you have that same set of atoms, and it's just how you arrange them, right? So just like when you're a kid and you had some Legos, you had the ones you could build a bunch of different things with those same pieces. Well, that's what this is. So for example, if you have something that has 4 carbons, 10 hydrogens, how many different ways can you arrange those, right? And one of them is you can make this kind of linear chain, right, where it just goes straight across. And here you have one that's branched. Right? Same idea, right? We're taking carbons and hydrogens and putting them together. Just the orientation we put them together can really matter. One thing you'll find is even when things are made up of the same atoms, there actually can be drastically different. Right? And so constitutional isomers don't always necessarily have the same properties. Right? Even here, you can see the boiling point has kind of a significant change, but we can even have different functional groups. Right? And so the properties of constitutional isomers aren't necessarily always similar. So it's just one thing to keep in mind that even though you're made of the same stuff, you could have drastically different chemical and physical properties. Right, so as you're following along, I would put a star by this page. This is something you're going to use a lot. When we're naming organic molecules, what we're going to do is be very systematic. And where we're going to start is the number of carbons, right? That's going to be the first place you start. Right? So any molecule that has 1 carbon is going to have the base name of methane. If you have 2 carbons, it's ethane, 3 carbons, propane, 4 butane, 5 pentane, and we'll keep going all the way through with hexane, heptane, octane, nonane, and decane. So when you're looking to name the molecule, you're going to start with finding the longest carbon chain. We're going to talk about this here in a second. That carbon chain, so 1 carbon, you're always going to associate with methane. 5 pentane, 8 octane, and I'm just picking some examples. Okay? The number of hydrogens you don't really need to memorize. They're just going to follow suit. And what I mean by that is when you draw out the molecule, remember, you're just going to add enough hydrogens to make sure that everything has 4 bonds. Okay? So I'd commit this page to memory. You're going to need to know up to 10. If you need to know more, you can always look them up. It's not a big deal, but you want to keep this in mind because it'll let you work through problems kind of quickly and a little bit more efficiently. All right. And like I said, if you need to look these up, we can always do it. The next kind of nuance to this is, I think on the previous page, I told you that it was methane, right, for 1 carbon. What we're going to see is how these 2 specific groups tie together. That the first part, the prefix, is going to tell you the number of carbons. Right? And on the previous page, we only did 10, but you can definitely find up to as big a number as you want. The second part of this is the ending. So here it's ane, so ane. Ane is going to tell you that it's an alkane, right? That is just carbons and hydrogens. So if you have a molecule that has 4 carbons and it's an alkane, then we'd put the 2 together. So 4 carbons is bute. It's an alkane, so we use ane, so it becomes butane. And that's what we saw on the previous page. We have something with 6 carbons, it's going to be hex. If it's an alkane, then it'll be hexane. Right? And this is going to be important because as we move forward, as we learn different groups, we're going to keep using these numbers, and actually we can use all of them, but I mainly only give you examples up to 10, is that you're going to use that same prefix, and we're going to keep changing the ending based on the functional group of the molecule. Right? And we're going to put this all together, but this is kind of letting you see where we're going. All right, so one of the other terms as we work through these problems that you'll see me use a lot, and you should commit to memory, is when we're naming a problem, the first thing I'm going to ask you to do is find the parent chain. And so the parent name of a molecule is always the longest carbon chain. Right? So longest continuous carbon chain. Doesn't matter if it zigzags, twists and churns, goes back and forth. As long as you don't go over a carbon more than once, it counts. Right? So the first thing you want to do when you find the name of a molecule is find the longest carbon chain. Right? And so this naming is IUPAC. And so it's an international naming system. So the first thing you're going to do is find the parent chain, which is the longest carbon chain. Anything that's not on that parent chain is going to be called a substituent. Right? And let me show you what I mean. So if you have a molecule, we're going to find the longest carbon chain, and the longest chain is right through the middle here. Okay? And we actually can't go down and then back up because then you're over tracing the same atom twice. So you got to just go straight through. And then anything we don't highlight is going to be our substituent. So all the atoms in orange are my parent chain. This one group here is my substituent. And let me just highlight these so maybe we can keep them to kind of help highlight what we're talking about. This will be my substituent. And so anything that's branched off is our substituent. All right. Now, one more wrinkle to this. If it's the parent chain, we'll use the ending ane, right? So for example, here it'd be 1, 2, 3, 4, 5. So 5 carbons is pent, and then it's an alkane, so it'd be pentane. We have 1 carbon here though. So instead of saying methane, if it's a substituent, we're going to write the term methyl. So we'll use the ending YL. Right? So the YL is going to tell you that it's a substituent, that it's a branch. All right, same thing. 2 carbons would be eth. And then if it's the whole chain, it's ethane. If we're saying it's a substituent, right, then we're going to add Y out the end, and so it'll be ethyl. So if we're looking over here, this would be my methyl group. And then this group here would be my parent chain is pentane. All right. And so we're not done. We're going to put them together, but I'll do that here in a second. So we'll see how we can organize these. So just really make sure you're paying attention that the parent chain is that longest continuous chain, and it's going to end in ane. So it'll be whatever the number of carbon is, and then ane. And then if it's a substituent, we put YL at the end. So if it's 1 carbon, it's methyl. If it's 2 carbons, it's ethyl. Sorry, 1 carbon methyl, 2 carbons ethyl, 3 carbons would be propyl. And we're going to practice some, so we'll put this all together. But let's do this together, kind of going stepwise, and I'll let you practice. All right, so if you have a hydrocarbon, the first thing you want to do is find the parent chain. All right, so this is just for alkanes right now, and then as we progress through the course, we'll find the nuances for different groups. So the first thing you want to do is find the parent chain. All right, so you're going to go through, and we've already done it here. And our parent chain is right through the middle. Okay. Once you have that, you're going to number it. Right, so we numbered here 1, 2, 3. And so that's my parent chain. And so that's where the term propane comes from. Right? So it's 3 carbons, so it's prop. And then since it's an alkane, it's propane. Now, just like on the previous example, this one group on top wasn't part of the parent chain, and it's just 1 carbon. So it gets to be methyl, right? Meth means 1, and then the YL tells you it's a substituent. And then the last thing about this is just like when you send someone mail, right? It's not like if someone was sending you something here to the college, they wouldn't just say Turnpike Street, right? They have to say 315 Turnpike Street, or your home address, right? There's always a number and a street. So same thing here. You're going to have your number, right? You're going to number your chain, and then you're going to tell us specifically what carbon that is branched off of, right? So it's on carbon 2, so that's why it's 2-methyl. So if we're going through the carbon chain, we know that substituent is on carbon 2. Right? One question you might be asking yourself is, how do I know where to start numbering? You're going to number from the side that gives your substituent the lowest number possible. All right, so if we look at this one down here at the bottom, we have the choice. We can number here in blue, where we go 1, 2, 3, 4, 5, or we can number on the right and go 1, 2, 3, 4, 5. Right, so the choice is, do we want the blue numbering or do we want the red numbering? And you want the red one because we get to that substituent the fastest. Remember, your substituent is anything not in that parent chain. So I'm going to highlight the parent chain in orange again, and my substituent in green. Now, one thing you want to pay careful attention to is, since we were little, we've always been taught to read from left to right. So instinctively, you're going to want to number molecules just like we have here in blue, right? Because that's just how we've been taught to read forever. It doesn't matter if you start at the top and work your way down, left to right, right to left, bottom up. You just want to go through the molecule, and you're going to start from the side that gets to the group the fastest. And like I said, we're going to put this all together. I'm just kind of going through all the rules, and then we'll do some examples together. All right, if there's 2 more identical substituents, right? So this is only if they're the exact same groups. Like if you have 2 methyls, then what you can do is combine them by using the prefix di, tri, tetra, right? So di means 2, tri means 3, tetra means 4. It says not used in alphabetation, and so I'll talk about that here in a second, but it's kind of a good note when you go back. And we're going to use commas to separate numbers. So the way this works, let's look at the one in red. So our parent chain goes right through the middle. And in this case, we have 2 substituents. I'll highlight them both in green. Each one of those is a methyl group. That one's a methyl, right? Meaning 1 carbon, and that one's a methyl. And so since they're exactly the same, we can put these together, and we'll use the prefix di to tell us there's 2, And so we can write dimethyl. Now, just like before, we have to tell everybody where those methyl groups are. We want a number from the side that gets to one of them fastest. Doesn't matter which one. So in this case, we could put something in the 2 position. If we numbered like we have here in blue, we wouldn't get anything to the 3 position. So that's why we picked this one on the left. So it's on carbon 2. So we'll just put both a number. So 2, 4, dimethyl. Right? And so that's where that comes from, is we're just putting the dimethyl right in front. And then our parent chain always goes last. All right, so that parent chain of carbons always goes at the end. All right, so this only works if they're the exact same group. If we had like a methyl and an ethyl, then we'd keep them separated. And that's where we would use the alphabetation. Okay. All right, so let's look at exactly that. So if you have 2 or more different groups, right, so if you have 2 or more different substituents, all right, we're going to alphabetize them. We don't ever alphabetize the parent chain. So whatever the parent chain is will always stay at the end. We only alphabetize the substituents. Right? So in this case, our 2 substituents is this ethyl group and this methyl group. Right? Same as before, we're going to number from whichever one we get to faster. Right? If they're the exact same distance, right? Because here we can go 1, 2, 3, 1, 2, 3. The second group is in the 5. Second group is in the 5. Then our last tiebreaker is alphabetical. And so we'll give the one that comes alphabetically first, the lower number. All right. So if it's the exact same difference in terms of how quickly you can get to a substituent, the next tiebreaker is alphabetical. And so that's why this one wins. All right, and let me actually just change the coloring of this one just to do one more thing. So remember, ethyl is 2 carbons. And I think sometimes with the zigzag, it can be a little bit tough to see. So there's a carbon right here in the middle and a carbon here on the outside. So 2 carbons is eth, and then since it's a prefix, it's YL, so ethyl. And then 3 tells us where it comes off of that parent chain. There's only 1 carbon in green, and so that's why it's methyl. And then our parent chain always goes at the end. One more thing, just be really careful that you're never using the di or tri. All right, so when you're alphabetizing these, you're only ever using the first letter of the actual word, right? So it's methyl or it's ethyl. You're never using tri, di, tetra. And the reason I point this out is it's really easy on a homework or an exam when you're kind of rushing through. If you're reading this, it actually looks pretty good, right? Because if you're just kind of skimming it and you see that dimethyl, you're like, yep, di comes before E, so D versus E. Yep, it's alphabetical, but you don't use, and let me put it in red, you don't use the di as part of your alphabetation. And so now, if you're highlighting the M and the E, you're like, oh, it's backwards, all right? So just be really, really careful that it's the actual root word, not the di and tri for your alphabetation. All right, so let's give it a try. So if you feel good about naming it, go ahead and pause the video. If not, we can go ahead and do it together. All right, so I think the first thing you should always do is find the longest carbon chain. Okay? And so I think for this one, our longest carbon chain is right through the middle. Okay? And so then if we number these, it's going to be 1, 2, 3, 4. And in this case, it actually didn't matter which side you start on. If you start on the left or on the right, you're going to get to a substitution equally as quick. So it doesn't matter. All right, so for 4 carbons, the prefix is bute. And then since it's an alkane, remember, it's just carbons and hydrogens. So if it's just carbons and hydrogens, it'll be an alkane. So our parent chain is going to be butane. All right, and so we know that always goes at the end. All right, now, once we have our chain, We've already numbered it, but we can do it again. We want to name the groups. Okay? And so if we look at this, these are each one carbon. And so if you remember, one carbon is methyl. And then since there's two of them, we can use the prefix di, and we'll say the numbers, right? So the way we're going to do this is we'll write 2,3 dimethyl, and then we put our parent chain at the end, butane. All right, so the name of this molecule is 2,3 dimethyl butane. And then let me again just kind of highlight where the groups came from. All right, so the first thing you're going to do is always find the longest parent chain. And then after that, number it. And we want to number it from the side that gets to the substituent the fastest. And then the parent chain is going to go last, and all the substituents get alphabetized. All right, let's try another one.